Cool. So let's get started then. We're really happy to be joined by Rex Groves. He's uh, representing the hardware factors team of the UAP division of the American Institute of Aeronautics and Astronautics. So we're happy to be joined by him, and he's going to tell us a bit about the different kinds of detection systems and different kinds of engineering requirements needed to detect UAP. UAP, like, are unidentified anomalous phenomenon. So we're, and this event is kind of run through the Yale Student UFO Society. So we'll give it up to Rex now.
All right, thanks, Sri. And hello, everyone. Thank you for taking time out of your day to attend this. Just give you a little bit of background. My background or my training is in physics, and I've never really been heavily involved in the UAP or slash UFO world, mostly in the astronomy, astrophysics world. But a couple of years ago, I happened to be listening to a Joe Rogan podcast where a Navy pilot had appeared, and you may have listened to him recently, Ryan Graves. And he was on a training mission off the East Coast in an F-18, and they had just installed new radar systems, a new radar system for their F-18s. And they suddenly started to see some of these objects, whatever they were. They couldn't really identify them. They were relatively small, somewhat smaller than an F-18, but they seemed to be hanging out there and observing. And after a while, there was some concern that they were a flight hazard, because one of them zipped in between two F-18s, and they had to cancel a mission, or not a mission, but a training mission. So there's Ryan being involved in the air safety piece of it, was involved in getting this moved up the chain. And this has been going on for some time on the West Coast. Of course, we've all heard of the Nimitz incident, where UAPs presented themselves, again, a potential air hazard, aircraft hazard. Someone, one of the Navy pilots indicated, I almost hit one of those things. So no one really has understood what they are. And we'll go over some of the unusual characteristics involved in these UAP, but they appear to have some unusual physics or unusual engineering that allows them to do things that we just don't know what they are. Now, just in case you're wondering whether this is real or not, I mean, the Department of Defense, the Pentagon, has come out and said, and basically in 2017, these are real. There's something out there. We don't know what they are, right? There's no one's claiming anything, but they just don't know what they are. They know they have unusual flight characteristics. And so part of what Ryan then got involved in, Ryan Graves, was he was asked to become part of a AIAA community of interest group. And let's talk just a little bit about what the AIAA is. Bear with me, I'm still learning Zoom. All righty, it's not moving. 1 moment.
Maybe we could try putting your thing in full screen.
There we go. Okay. Maybe that's what it was. So what we're going to do a little bit today is I'm going to go over a little bit, not very long, about what the AIAA is and what the UAP Integration and Outreach Committee does, which is what I'm part of. And we're going to talk a little bit about the unusual physics of UAP, some of the scientific implications, some of the key projects that we're working on here in the Hardware Factors group. And again, hopefully discuss a little bit what may be opportunities for academic involvement in the study, and talk a bit about the work ahead. Again, when Ryan became involved in the AIAA, we basically, what the AIAA is that it's a platform where experts, engineers, and scientists involved in aeronautics and in space, near Earth orbit, R&D, they all get together with their various expertise in various companies like NASA or the primes, the military primes. And they get together and it serves as a platform for them to share ideas, to network and collaborate. It's just like the physics or the chemistry communities. They have their own groups that get together and share ideas. And that's what we do here at the AIAA. They have many, many different kinds of committees, technical committees that focus on specific technical areas in aerospace. So it's very specific. If they're working on drones, then they have groups that get together about drones. If they're working on aircraft frames, then they would have a particular group for that. Our group, there are other groups in which we are involved that are a little bit different. They're called integration and outreach committees. And this is differentiated from the technical committees in that we're cross-disciplined. In other words, we don't just have aerospace engineers necessarily. We have many, many different types of disciplines. So I got involved here, again, listening to Ryan speak on a podcast, again, and indicating that they needed some expertise to come in and to help with these the analysis of the UAP phenomena, at least in the detection scheme. So I joined the group, and now 2 years later, I have the pleasure of leading that group as the chair of the hardware factors group. And we'll talk about what that is. But primarily, it's a little more, it's differentiated from the technical committee in that we generate our ideas, our methodologies, and then we have outreach to our customers. And our customers may be the Department of Defense, academia, individual groups that get together that need input from experts. So that's what we do as a group. So our specific IOC, the one that I lead for the AIAA, is primarily we're improving. Its charter is about improving aerospace safety, and again, aerospace, the atmosphere and near Earth orbit. Right, we're involved in a lot of at least monitoring of spacecraft launch. And so that kind of thing involves safety, especially if there are particular things flying around up there that we don't know what they may be. The key is this, and this is what I'm most proud of in the group. We're data driven and we're neutral. So the UAP, its meaning is unidentified aerial phenomena. Its old name, UFO, was unidentified flying object. And it went around for some 50, 60 years under that nomenclature. But it turns out that this phenomena is more than just flying stuff up there. It crosses domains. We have things that are flying. We have things that fly and enter the water and like it's not there, that move under the water at incredible speeds. So it's a phenomena that crosses different domains. So it started with they went from UFO to unidentified aerial phenomena. Then when it started showing up in the water, then it went to unidentified anomalous phenomena. So it crosses all those domains. But we're data driven and neutral, and we like to call it it's under red, green, and blue. So we don't claim to know what it is. We don't have a preconceived bias on what it is. We don't live in YouTube world or on UFO Twitter. We don't live there. We live in a data-driven environment. So we look at this phenomena as under red, green, or blue. Blue meaning it may be U.S. military aircraft or new technology from the U.S. And we just don't know what that is, and it's being kept classified. So we will treat that just as we would anything else. Red means it may be an adversary. It could be a leap in technology from an adversary, or it could be an ally. You just don't really know. So we pull that under the red umbrella. And green, we just say it's something else. We don't know what that is. So red, green, and blue. But we have a technical team of experts who advise staff, and we amplify our work for our stakeholders, the people that want our input and guidance when it comes to this particular phenomena. The experts that we have within our group, we have roughly 20 people that are heavily involved. We have extended membership, of course, but the 20 that are heavily involved in the hardware factors group consists of physicists. We have propulsion experts, radar experts. We have academia and astrophysics, and of course, aerodynamic experts as well. So from that, we're able to break into different teams. And if someone requires our services, then we're able to put together the appropriate group that can do that. We originally formed to gather data. There was some work about a little more than 2 years ago to work with the government UAP task force. I think it's called AARO today. That's the All-Domain Anomaly Resolution Office. And we were trying to work with them so that we could get access to some of the classified video, some of the classified data that we could at least help them to get that job done, either to debunk or to reinforce what we were seeing. But that never truly worked out. It's really very difficult to get through the government classification system. So, but at least presently, we do have aero involvement in our team. So we do have that going for us, and they're very helpful. So basically, we are in an advisory status. We go to conferences and forums. Once a year, we go to aviation and Ascend, which is space and technology. And we present papers on the detection scheme. To give you an idea, UAPs used to be a poison word. I mean, UFO UAP, if you even went into it in academia, it was a stain on your reputation because there was real science to work on, right? So it's still a thing where you have to be somewhat careful in academia. So we're trying to, again, keep it above board and not be unusual about it. So part of what we're doing, again, is we peer review papers that come out on the UAP itself. There are plenty that are out there that people put together a documentation and want peer review, and then we supply that as well. So that's part of what we do. And again, our stakeholders, again, are government, academic people. And we also have a separate group, which you'll hear from in a couple of weeks. It's called the Human Factors Group. And that's where we actually take testimony from pilots, military and civilian, and attempt to garner data from that, from those interviews, and maybe be able to build a framework at which we can learn something. So the data we work with, right now we haven't dealt with any classified data. We're starting to gather some non-classified data to work with. And we self-generate data. We have our own internal projects that we go out and do ourselves to try to generate and try to capture these objects in whatever way we can. So the bottom line is the objects are real. We don't know what they are. And our mission is to try to gather data. And we fall under three different, the framework that's a triad: detection, evaluation, and characterization. So the dominant part of our work right now is detection. We use any and every way that we can think of to possibly detect these objects. So let's talk about it for a minute. So it's what we don't do as the Hardware Factors Group is try to invent new physics, right? We hear it heavily that these objects are defying physics. Well, there's no real evidence that they are. There appears to be advanced engineering. We're going to go through some examples here shortly that'll blow your mind. But they appear to have some advanced engineering, but there's no real evidence that there's new physics. Now, there may be, but that's not our job. What we're looking at is this. Let's say, and I'm just making this up, I mean, you hear commonly that there may be anti-gravity. I don't know what anti-gravity means. As a physicist, it doesn't mean anything to me because it doesn't fit any known models that we're well acquainted with. But let's say it did exist. Well, obviously, these objects are interacting with our space. They show up, they give off light. When you look at them at night or even in the daytime, they're giving off light. So that means they're interacting with our physics, our environment. They're reflecting radar. That means they're interacting with our physics and our environment. So what we try to do is not to invent the physics or try to come up with a new propulsion system to try to understand it. We try to say, given that perhaps it's an exotic propulsion system, given that it may be exotic physics that does warp gravity, what would be the detection scheme that we could see it, right? How could we detect that? Because all things in physics, there's interactions that go on and they interact with our world. So what sensors can we put in place that if that hypothesis holds, we don't have to discover its origin. We just have to discover, wait a minute, if we get this signal, that would imply that it's this. So we work from the data and work our way up. We let the experts do the physics and we try to do the detection. So that's what we as a group have been trying to do, looking at sensor systems. Because we don't have access to the advanced technology that the US government has, we go to commercial technology. We've been looking at NexRad Radar. Can we correlate NexRad Radar signals to new types of, to a particular UAP event? Could we see it and learn something from it? So we use radar, we use the electromagnetic spectrum, we use acoustic methodologies, all of those things that will try to get us a clue to what these are. And then we characterize it. So AARO, which is the UFO office, has reported a number of UAP events, and they've collected them into certain categories. They travel speeds of about exceeding Mach 2, and that's low. We have one instance where it was Mach 350. It's insane, right? So they definitely exceed, they're hypersonic in speed, and they are able to go from sea level to near Earth orbit in under a second. So it's pretty phenomenal. And then what we want to do is once we if we learn anything or we have, if there's something that we want to recommend, then we do provide, say, pilots. For example, just to bring up an example, we're getting a lot of confusion lately with Starlink satellites. So there's Starlink constantly being put into orbit, and pilots are still learning what these look like, right? They show some unusual characteristics than the normal satellite that you see going across the sky. So we try to give some feedback into what to expect to pilots so that they're not overly concerned about what they're looking at, that kind of thing. Let's talk a little bit about the unusual physics of UAP. Now, this is what we get involved with in the hardware factors group. Again, given these things that have been observed and measured, we're not talking one-off metrics here. We have multiple dozens of radar signatures that give these kind of views. So one thing you'll see is the extreme accelerations that they go through. In the Nimitz incident in 2004, I think we've all seen on TV and on YouTube about the Tic Tac, right? You'll see the Tic Tac video. This thing descended from 28,000 feet to sea level in less than a second, right? Now, that doesn't sound too terribly by itself extreme, right? Okay, it's really good. It just fell from the sky. No, it had to accelerate from the sky to get there in less than a second. If you calculate the G forces involved, 5,000 Gs. That something the size of an F-18 fighter went from 28,000 feet to sea level under 5,000 G of stress. That's incredible. To do that, if you calculate the energy requirements to do that, it's 10 times the nuclear output of the US out of a Tic Tac the size of a fighter. Now, I don't know what this means, but that's insane amount of energy, right? And think about that. There was no noise. The energy didn't get dissipated. How is this happening, right? It's unusual. So what we have to think about from our group is, if this is a common occurrence, how do we detect something like this? If this energy is going somewhere, how do we do that? We see that they routinely hit hypersonic velocities. Matter of fact, this list, I want to give due credit, came from the Seoul conference, Dr. Kevin Knuth. I gave a YouTube link here. It's very interesting to listen to if you want to listen to it. This is just a summary of his observations, but this is what we use. But we're seeing these things typically hit hypersonic velocities. There was a JAL aircraft who's on radar measured one of these objects in his flight path. They were going from Japan to, I forget, to San Francisco. I might be wrong there, but they were flying over Alaska. And they measured the speed of this object at 270,000 miles an hour at Mach 350. That sounds like it's made up. It has to be a sensor issue, right? There are dozens of these measurements, dozens of them. No sonic boom or plasma trail. You would be ionizing the atmosphere at those speeds, but nothing. So these are things that we would say, okay, what's going on? What can we learn from that? We've recently learned that these objects go through transmedium travel, and it's really kind of a recent development. They move seamlessly between space, air, and water like it's not even there. You don't see any deceleration whenever they enter. The Tic Tac came out of the water and then went right up into suborbital location. Here's one of these things that we're making use of right now. It's number 4. They have high luminosity. They glow for some reason. I don't know why. We're trying to find that out. When you see them in the daytime or the nighttime, they're giving off light. So the key is, can we get some spectrographic analysis of what these are? And I'm leading a project that hopefully will be able to do that. And we'll talk about that shortly. But if you just measure the luminosity in the sky, it comes to about 30,000 megawatts just for the glow. If you look at the spectrum of that light given off, it should be at about 30,000 megawatts just for the light. So they're not hiding. But what is the physics behind something like this? I don't know, but all I'm looking at is there's light. And if there's light, it can be analyzed. So that's what we try to do in the hardware factors team. We do know that they do have strong electromagnetic and magnetic field effects. And at least when cars were under a different technology, they would stall. They would interfere with the starting system. Modern cars, not so much, but there was indications of these strong fields. And what photographs, if you take polarized photographs of these objects, you do see this interference pattern indicating a strong magnetic field. The other thing I think I mentioned earlier is there's no observable energy deposition. One of the basic tenets of the universe, right, is the conservation of energy. So if this UAP is going at hypersonic speeds, suddenly comes to a stop, where'd all the energy go? Right, there should have been an explosion. There should have been a rush of air to displace water. I mean, there should have been something, but there's no evidence of this. That Tic Tac maneuver, again, and it shows this energy in equivalent to 250 Tomahawk missiles. It's insane what's happening. And then as from a physics viewpoint, you would have to say, okay, at these speeds, you're starting to introduce, you're not quite there, but you're starting to introduce a few relativistic effects. If you're going at that speed, you're nowhere close to the speed of light, so it's not going to be large. However, that's still fast enough that you should see differences in clocks. I mean, we do know that just our geosynchronous, or I'm sorry, not geosynchronous, but our GPS satellites have to be time adjusted because of the relativistic effects. of being in a gravitational field. So maybe there's a way from measuring time that we can get some idea of what the propulsion system might be. Absence of any known propulsion or control surfaces. These things are all different sizes. They're different shapes. They're orbs. They are tic-tac shape. They look like blobs sometimes. They look like diamonds. There's all kinds of different shapes from these objects. So there's just a recent release on YouTube. There's a team called Skywatcher. They're out and trying to capture some of these events, and they have a nice dictionary or topography of each of these different kinds of craft that they're seeing. Again, no answers. We're starting to look more underwater. There is more and more evidence that there are underwater events. There was a ship in New Zealand that it was on a mission where it would go out, turn around, and then look back with sonar to see if someone was chasing them, right? So I mean, it was a cat and mouse kind of assignment. Well, then they noticed on their sonar, there's an 800-foot object out there, and it's been following them. It's 800 feet long. That's bigger than a submarine. And when they tried to do evasive maneuvers, this thing closed in on them underwater at 3,000 miles an hour. Again, it violates some fundamental, it makes you think twice. Okay, let's say they do develop a technology that you can travel at that speed under the water. The pressure wave should be easily measured, and I'm using sonar. I mean, I'm using sonar to measure its speed, so it's responding to a pressure wave. But why isn't it producing a pressure wave when it comes to me? It's really mysterious. So again, we're trying to evaluate these kind of things to say, okay, what kind of sensor could you deploy underwater that could measure something like this? And then finally, one of the characteristics that we are curious about, there appears to be some kind of behavioral intelligence. We don't know if it's biological in nature, AI in nature. We don't know anything about it, but it seems to know ahead of time when we're searching for it. I think it was interesting that under Ryan Grace's experience, that this thing went back out to its cap point. Now that's the point at which these aircraft enter the airspace at which they're doing their maneuvers. It knew where it was at. How did it know that? It was not briefed. It's just, there seems to be, they have a way of finding out things that are mysterious. So these are the things that we look at. Again, we're not trying to invent the physics. We're not trying to invent a magnetohydrodynamic drive, even though we have some NASA scientists that are working on those very things, right? So we're leaning on them. Okay, if you're using such a drive, then what would be the detection scheme? And how would you evaluate it? And that's what we want to try. So the scientific implications are real, and this is what we care about. Again, I like anybody else, want to know what it is, but there are bigger impacts to humanity, right? If these power requirements are this large, that's free energy from our perspective. So if we can get an idea of how to measure it, maybe we have a clue for free energies. Structural stress, accelerations of 5 to 10,000 Gs, it shreds anything we have. So maybe Star Trek had it right. There are inertial dampeners out there, right? So there may be some kind of things we can learn from it. Being able just to eliminate sonic booms would be tremendous for travel, right? So that's something we want to know. Missing energy dissipation. Where did all that energy go? Well, then if we knew something like that, what's a mechanism for doing that? It could save lives just in catastrophic events. And of course, there's the unknown physics versus unknown engineering. So the tack that we're taking is that we don't think that there's unknown physics. We think there's unknown engineering. And that's the lens at which we're looking at. Because otherwise, if you're throwing out your physics, you wouldn't know how to measure anything. You've got to assume that at least we have a good idea of what the physics, at least a measurement, what physics are there. We in the hardware factors group have a lot of us that are working on we have like 5 primary projects right now. We're looking at NexRad Radar. I think I mentioned it earlier, and primarily NexRad Radar has its own filter inside to clear out clutter. So we're trying to get a hold of the data that doesn't clear out the clutter, so that we can see if there's anything anomalous. So that the data is out there, and we just have to go out and get it. So that's why there's a group of us, some radar experts that are going out to look at that. We do some little fun projects. What we're finding, there's a real appetite for a lot of people out there to set up remote sensing systems. Here we have a former NASA astronaut that has noticed unusual activity near Mount Rainier. Now, who knows what it is? No one knows anything, but with the new technologies that are out there, we're going to take some all sky cameras out, maybe a PTZ camera, and just set them up and let it monitor. It's just because there are some activities also going on across the US of some mobile UAP sensing systems. AARO, the US government's UAP sensing system, is called GREMLIN, and that's got some infrared cameras, optical cameras, radar, a lot of different little things that they can take it to a hotspot, so to speak, where there may be some UAP activity, and see if they can capture data on it. So they're heavily involved in that. There's a group up in Long Island called Nightcrawler. They're doing a little lower tech view attempt at the same thing. They've done some good work. So I've been up there to take a look at what they have. So they're using some cameras across the spectrum to try to get UAP activity that they're seeing out over the Long Island Sound. So that's what these are. Again, this is what our team members are involved. This is one that I'm leading and started. Again, light is everything. To me, light is everything. So a lot of the images that we've been getting in the public and from aircraft, they're in the optical range. But what they don't give you is spectra. They're taking it, they're just dividing the light into 3 bands and you get a picture. Or you're looking at it in infrared and you're just getting a heat signature. I've acquired some hyperspectral cameras, and hyperspectral cameras are different. Every little pixel contains a spectra. So if I took a picture of your face, I could pick every little pixel in your face and get its independent spectra. Why do I want to do that? Well, if you're made of a particular material, you have a particular spectral signature. If I look at an aircraft, I can tell you what it's made of, because titanium may have its own signature. It absorbs light at a particular wavelength. So, but however, what we're doing here is the opposite. So in northern Alabama, we have these lights that show up. We think they're just, and I'll say it, swamp gas, right? But there's some kind of local phenomena that causes these glowing plasma balls to rise. So we're putting hyperspectral cameras on it to see what emit. There we'll get an emission line, and that will identify the elements inside. So it gives you both ways. It tells you if there's elemental signature, and it can also tell you composition signature if you look at a UAP. So this is our proof of concept. So we're working this piece. Hyperspectral cameras are relatively recent, very notoriously difficult to use. So there's a challenge. Also, we have an observatory site down in New Mexico. So it has a 0.5-meter telescope with a tracking platform that can track orbital systems. And it's all integrated to where if there's an anomalous light in the sky, or at least we're getting there. We've got the software finished. But if there's an anomalous light in the sky, it'll check to see, okay, is this a satellite? Yes, no. Is this an aircraft? Yes, no. Because there are databases that it can cross-reference to determine this. If it is not, it'll swing there and we'll get hyperspectral signature. That's the goal. That's what we call it the Angstrom Project. So we're going to get signature all the way through the visible, NIR, all the way up to the long-wave infrared. So again, these are all projects. Again, because we can't get government data, we're generating our own. And finally, it's really difficult to get radar approved inside the US for a private individual. You just can't do it. I mean, marine radar you can do easily because you have to put it on your boat and you're out in the water. But on land, they don't really like that. So, but you can do something called passive radar, where you're using a signal from the local radio stations or some other source, and then notice deviations in the patterns that they give out. And from that, you can determine direction and speed. So we have a project here that uses software defined radios, and we'll be trying to implement this in the field. Again, all scientific approach. So that's what we're doing, right? We're attempting to grab the data that we can do, but we do always need help. I mean, new ideas are constantly coming out of academia. And these elements here are the 5 that we think we need the most. Always in the physics, how you model more. I mean, AI is now entering the physics world a lot more than it used to in terms of classifying things, right? So gathering data and simulating, coming up with a regression models, things like that. AI does really well. Engineering can, what kind of radar detection platforms, computer science. There's the reason why we say neuroscience bio. There, I'm just going to say it and then I'm going to walk away from it. There's some reports you've heard these whistleblowers in front of Congress. Ryan was one. However, there were others like David Grush and Louis Elizondo that claim we're in possession of non-human intelligence, right? Of biological samples, non-human samples, non-terrestrial samples, I should say. So if that were the case, let's say we came across a novel sample like that. How would you evaluate it? What if it's not DNA or RNA based? How would you evaluate it? So that kind of is how academia can get involved. And of course, there's always the philosophy policy, because what is still a big unknown is disclosure. Let's say that it is disclosed positively that we're not alone, right? How would you handle that? How does that address? Is that going to be addressed? So again, I just throw a bunch of ideas here at the end of ways that you could do that for each of these. I'm definitely not going to go through this, but you can feel free to share that screen to everybody that wants it. All right, different ways that you could help in that area if you wanted. So again, we're looking for collaborators across all domains. If you think you can help, we'll gladly involve you, right? In whatever way you'd like to do. And because we have real world roles for students, professors, professionals, whatever ideas are welcome, right? So that's where we're at in this. Any questions? I'm now going to stop talking. I don't do death by PowerPoint, but I do a near death experience. So I'll turn it over to you.
Cool. Cool. Thank you for for your wonderful talk. So Rex is a consulting physicist for the Food and Drug Administration and has worked in the Pentagon in various roles throughout his career. And also, like a lot of members of the hardware factors team, they're university professors and former Defense Department officials and all sorts of very diverse roles within various aspects of government and academia. So, and I guess a lot of you guys are like pretty busy, right? So can you speak a little bit about, this is sort of a volunteer role at this point within AIAA.
That's correct.
So can you speak about maybe like the challenges sort of time-wise and coordination-wise, and what kind of like funding structures, like how are you able to like fund these projects? Is that like something that makes it tricky?
Yeah, it does make it a little tricky. Like the work that I'm doing is self-funded a bit, but there are a number of us that are involved in government contracts that they're able to piggyback the work. In other words, they'll be able to get permission from the prime or whoever it is they're working with to run their own side project as long as there's no uh, classification issues or proprietary material. So that's we're doing one project like that as well. So yeah, it's a little challenging. More recently, we're starting to get more access to data from other groups that are interested in verification of their work. So there's always that's what we've been waiting on. When we first formed, we were hoping again to have access to government data, but that didn't occur. So we've had to work at this. So it is a little tricky in terms of how you fund something like this. But again, a lot of it though can be like we have one individual that is involved in the AI piece of it. So he can run his own, he has his own system that he can do that with. So it really depends on what you're interested in and using what materials you have. That didn't answer it cleanly, but that's really how we're working right now.
Okay, great.
We don't have a budget that we work under.
And so can you speak more about like kind of the negotiations with AARO? So originally there was talk about collaboration. Like, was it sort of easy to interface with AARO? What sort of restrictions, like what kind of technical and legal things came up when it came to this like classified data?
Well, again, the issue is primarily classification. AARO, and again, I'm speaking generally here. I won't speak specifically for AARO because I believe from what I've heard that AARO has this complaint as well, that everything we overclassify in the US. We overclassify a lot. So if we don't know, we classify it. And so we were reaching out. I mean, Ryan was wanting to create, aerospace safety is the primary motive for why we work. Having data that we could analyze would be very helpful. And we were even looking at some of the non-classified pieces of what they have. But the former head of AARO, Sean Kirkpatrick, felt hamstrung quite a bit on what he could do, and it just never happened. However, the present administrator, Kozlowski, Director Kozlowski, has given one of his team members, a consulting physicist, permission to collaborate with us. And now he's on our team and he sees what we're doing. And then what he's trying to do is to give us non-classified access to similar projects that they're doing on a grander scale, right? So that's, I mean, like we're working a bit in hyperspectral work. They're flying aircraft up in the stratosphere looking at hyperspectral stuff. So again, it's a little more grand, but it's maybe useful information that we can use locally. So again, so we've made a little progress by getting one of their representatives on our team. And they were very wary about it because they wanted a science-based team. They didn't want ufologists. So that was a good mark for us that we gain their trust in that area.
Cool. Yeah, that's awesome. Yeah, hope that continues. So you said you also kind of collaborate with other civilian UFO groups, for example, like other kind of academic groups that have risen around this topic would be like the Galileo Project over at Harvard with obviously and
Yeah,
like UAPX. Are those examples of groups that you've been interfacing with?
I haven't interfaced with UAPX so much. Kevin Knuth, I've met briefly, who's involved with UAPX. Javi Loeb, I met out at the Seoul conference in San Francisco this past year. He welcomes collaboration. I haven't really done that with him formally, but he's always open to that, and that's to his credit. So a number of people that I have interfaced with in some of the universities have worked with Avi, and then they're actually helping me. So I'm really working with Avi 2 levels down a bit, using some of his resources in terms of their expertise, not physical resources, but their expertise. So I'm in regular phone contact with various individuals that work the Galileo project.
Cool.
But UAPX, no, nothing yet.
Okay. Also, yeah, if anyone has any questions, I have a whole bunch of questions, but if feel free to jump in or put something in the chat. Maybe I'll give you a few seconds for people to collect themselves and unmute themselves.
While they're thinking, again, I just want to reiterate that our North Star is the physics, that we don't throw out physics. It's very common you'll hear it all over the internet that we're violating laws of physics. And what we've seen, I mean, we're sending people to moon, spacecraft to Mars, all based on 400-year-old Newtonian physics. Doesn't even use Einstein's theory. The point I'm trying to make is that any physics that might be more advanced than ours, if it's there, would be an extension of what we already know. I mean, special relativity, general relativity is an extension of Newtonian gravity. So we would expect that any new observation still would involve the physics that we know. I mean, quantum mechanics is a relatively new theory, right? The last 120 years or so. But quantum field theory that's replaced it didn't do away with quantum mechanics. It was an extension. So again, we expect that any new learning that we have will be an extension of what we already know. And based on that, any metric or any detection scheme should identify what they're doing. Even if we don't know how yet, it's telling us what. And that's what we're trying to do.
Cool. So are there any questions? Otherwise, I got a few more questions. Okay, so there's these different camera systems and so you have like BNIR, SWIR, hyperspectral cameras. Can you sort of, I think a few slides ago you had a whole list of things like LWIR, full spectrum
All that
optical.
kind of stuff, right? It's just an extension of our optical range. So as you go, it's just the electromagnetic spectrum, a different part of the electromagnetic spectrum. So as we get out of our optical range of vision, right, now we start seeing things that are hot. That's called the shortwave infrared. And that's used for determining objects that are extremely hot, or if they're reflecting light, it helps us to identify materials. And then as the objects get cooler and cooler and cooler, they move into what's called the midwave infrared. And those are objects that can, again, give you an idea of the propulsion systems they're working on. When you'll remember the drone incursions over New Jersey, the drone incursions over Langley, that's over the past couple of years, they've been NASA sent in an aircraft that looked at these objects in these wavelengths. There are different wavelengths of light that give you different information. So optical wavelength just gives you color, but these larger wavelengths give you an idea about temperature. And if I know temperature, then I have an idea what the propulsion system might be. That kind of thing. The hyperspectral cameras, if you would point it at an aircraft, you're probably going to see three peaks because the navigation lights have one in the red, they have one in the green, and I believe they have one in the blue. So you'll see three peaks. So you'll know it's a navigation light. But if it's a plasma, let's say there's a hypersonic object moving across the atmosphere and it's glowing, then a plasma spectrum will be different. It won't be three peaks. So these hyperspectral cameras give us an idea of what the physics is going on up there. So that's why we're looking at these in this way. And AARO is looking similarly in this region.
I have a question, if I may.
Yes.
Silvano Colombano here. Are you aware of, or how do you deal with reports of objects actually being found, or remains of crashes, or claims of reverse engineering or attempted reverse engineering, or any of these things? I'm assuming that most of these things, if real, is classified, unfortunately. But anyhow, what do you approach any of these issues within the AIA or anywhere?
Not in our team. We would love to be asked, but no. I have really mixed feelings about it. Again, I can't touch it. I don't know if I really believe it yet. However, there have been credible sources that claim there's reverse engineering going on. I don't know, but I do lean credence to Gary Nolan, who's a Stanford researcher who's got first-rate credentials, and he claims he has investigated material on an atomic level that appears to be manufactured. So I don't know what to make of that. He doesn't know what to make of it. He just knows it wasn't made here, or it didn't occur naturally. I mean, we're talking layers of bismuth, layers of manganese, these kind of, and why those atoms? There's no clear reason for that. He's supposedly picked up waste product from UAP events and has analyzed them. I don't know what to make of that. That sounds exciting, but I couldn't tell you. Again, I don't believe. I just go with the data.
Thank you.
Mhm.
So you were mentioning there's been hyperspectral data taken of these Langley drones. That's these Langley incursions and the recent New Jersey drone wave.
Yes.
And you were also talking with relation the similar technology. So that's probably, I would imagine, largely classified. But these Earthlights data, that's your own data that you've collected.
Yeah, it'll be whatever we find will be public. Won't be nothing secret.
Okay. Can you so I guess this image that you took is pretty recent, within the last 6 months.
Yes.
Can you comment on how much data and what different kinds of pictures you've taken and what they sort of look like? Do they seem kind of prosaic at this point, or is there kind of interesting things that you can report on?
Yes, they appear. And again, I don't have any idea what these are. And again, the reason we're looking at this as a hardware factors group is to test the viability of using hyperspectral for UAP events. I mean, somebody's going to claim they've seen a UAP. Matter of fact, here in Alabama, I walk around town, people claim they're UFOs, right? So we need to answer the question. And that's part of what we do as well, is to say what it is not. So yes, we got a lot of these kind of pictures. They're in the daytime. they're 3 to 8 feet across. And the feeling is that, or our hypothesis is, they're just plasma orbs that are being, and again, the hypothesis is that this is a high radon activity area. It's a level 1 radon. That gives all, that's an alpha emitter, which could be kicking it off, could be igniting the atmosphere in some way, and it creates this sphere. But hyperspectral data will tell us. And the challenge is the cameras don't work very well in low light. So I'm modifying them to do so.
I see.
But
So
it's just a classic case of, okay, here's a hot spot. This is what what you do as an investigator. There's a hot spot, you go check it out, throw some science on it, and hopefully you get something good out.
so maybe with this Earthlights project, is there are you able to deploy other sensor systems? Like, for example, do you have other kinds of passive and active radar systems that can locate these objects, or are you able to like cross-reference different data to like maybe pinpoint a location in the sky and also maybe track them? Like, or are they kind of static images? Like,
Yeah, well, what the approach that we're taking is that we're going to set up a couple of all sky cameras. And if you have 2 cameras that see the same object, you can geolocate it. So it'll be recording all night. Any one of these that come up, it will locate and track it. And you can stick it on Google Earth and get a track. So hopefully we'll have an understanding of where these are originating from a particular location, or is it just ubiquitous around the region?
I see. So
We'll have a passive sensor system to capture it. So we'll just be using standard light, nothing hyperspectral for that.
for the geolocation aspect.
Yeah, so we don't need radar. We just need 2 cameras to see it, and then it's easy. Simple math.
And for the so for the New Mexico observatory, can you kind of say, or so it's still like in the process of being built, these like these different systems? Is that, or have you been able to collect data so far?
Nothing
The Angstrom
yet.
project?
These systems are already in place. The optics are there. We have a 0.5 meter telescope. I use this. This was mine for, I took pretty pictures, astrophotography, right? I took pictures of galaxies and other nonsense. But now we're moving it over into hard science. So when the hyperspectrals are completed, then they'll be attached to this platform. And then that will be used to identify anomalous lights in the sky. The New Mexico, Arizona region is a pseudo hotspot. It's far away from everything except border drones, and aircraft don't typically enter this part of the region very often. So it's a nice place to not get false positives. So that's what we're looking at with this system.
Right. So I guess this project is kind of about retrofitting
Yes,
astronomical observatories.
correct.
Are there other kind of sites? I know, like in Hawaii, there's some nice observatories, and all over the world. Are there other kind of sites that you're looking to retrofit, kind of astronomical observatories, or like maybe like weather stations?
The movement is really moving toward mobile systems, because there's no real localized hotspot where they always occur that we're aware of. So the move has been to, can I come up with a mobile system that I can deploy pretty rapidly if there's a hotspot? Like there's supposed to be a hotspot near Monterey, which is where UAPX went. There's a hotspot near somewhere in Hawaii that a number of people have traveled out to. So once you get a good scientific package put together, then that's where this is all moving to. And that's why AARO went to the GREMLIN system. They had to be mobile. It's just too hard to sit and wait. I'm not sure the success this will have, because I'm just sitting and waiting, right? So, but dream big, trying to get data.
So this GREMLIN system, like, so AARO's kind of told you about this system, but have you been able to like get their data, or is like this GREMLIN data going to be under classification systems?
I don't have the answer to that, whether they will share it or not.
Okay.
I have another question or comment. The idea of the existence of hotspots, I feel has really profound implications. No matter how you look at the phenomenon, so there either the hotspot is because there's some physical phenomenon that happened in that area that creates these sightings, or there is some entity that's hiding somewhere.
Yes.
Colonizing us potentially. and I'm not seeing much thought on these implications, and I am wondering about whether the characterization also of the hotspots would be an interesting thing to do. I mean, we are trying to characterize the sightings, but not the actual hotspot itself. How is that defined? What's actually happening there? How often to make that to be considered a hotspot? Again, how many are there? Where? Why could they possibly be there? What's their nature, origin? Again, thoughts. I do to hear your thoughts around that.
Well, the AARO has put together a matter of fact, we're still sharing. I'll go to the AARO website here briefly. I think it's a gov site. No, it isn't. Let me just look it up what it is.
I think it's aero.mil.
Is it Mill? Yeah, that makes sense. All domain. Office UAP. There we go. Yep. So they have a list of hotspots, and I haven't been on here in a while.
Okay.
But I'll get to some conjecture here in a moment.
Mhm.
Let me do this one.
Mhm.
So I think yeah. So on here we have a picture of their hotspot. Here it is. You can see it's pretty crude. It's just really almost just a generalized location. And they've got the morphology of the UAP, and you'll see a lot of it's on the East Coast. Well, of course, it'll be on the East Coast because there's a lot of air traffic, that kind of thing. But what is being conjectured, and I'm not reading any more into this, this has come up at a couple of conferences, is that we're discovering more and more there seems to be a relationship, a correlation between UAP and water. That could be that, I mean, the Monterey sites, there have been some indication they've been tracked with radar out of some of the islands off the coast. So maybe they're hiding in water. That's why they're hard to find. So that's some kind of analysis that needs to be done in greater form. And again, orbiting assets will help answer that, but we don't have access to that yet.
Mhm. If one were to work on the conjecture again of terrestrial visitation. Water makes all the sense in the world because the water is an element which would be anywhere, in the universe. So that it would be an automatic atmosphere that will be um, acceptable to just about any entity from outside the Earth. And so that's an actually interesting to think about.
Right, it is. It is. And again, from our perspective, let's say they are moving through the water. How do I know it? How can I detect it? Right? That's what we'd like to know.
Right.
So a lot of the data sets that you're using to get this data, you're saying that they come from weather data. Are there other sort of like publicly available, just a big concept in sort of sensor systems and aerospace technology is like dual use technology where like both civilian and military, um, the same systems get used for like kind of both civilian and military. Are there like kind of generalized notions of that for like using dual use like weather system and being able to like tack on a hyperspectral sensor to like a weather system? Like what other kinds of like public data, like or maybe like space-based satellite arrays, is that
Yes.
useful?
Yeah, one of the satellite systems we like to try to use, or we've not really made an aggressive effort, are the weather satellites, GOES, GOES satellites. So, matter of fact, one just was able to see a Starlink or Starliner launch. So they have reasonable resolution. So we've not really investigated whether we can get those records or not, but that's been on our mind. Other things that are on our mind are to add things called sidecars. So, like in a military exercise, this is one area we were trying to do. They are testing their capability in a offshore, right, in a training exercise to get ready for deployment. Well, they have their radar systems up. If we can piggyback a small sensor that collects all the data before it's processed, then that's something we can play with. So there's been attempts to sidecar certain activities in the military. Again, we haven't succeeded yet in getting full clearance for that. It's just something that's been thought about.
Right. And you're going back to the whole idea of keeping all of the raw data, is that an issue that you said it's like difficult to kind of access the raw data because there's a lot of bureaucratic runaround. Is that an issue, like accessing the full raw data, or or do you only have access to the filtered data that's on public? And also like what kind of computing systems capabilities do you need? Because a lot of this weather data can be like really high intensity, a lot of data. Like is like the resources needed to collect all of the data and to not throw out your data? Is that an issue that you've come across?
Well, we're starting to discover you can't use a laptop anymore. This is all cloud computing type of efforts. So to collect that kind of data, we've had to break it up into pieces, like with the NexRad stuff that we're working. It's had to be broken up into pieces, like we focus on Jacksonville, Florida, say. Well, then that you can do it from that perspective. If you want to look at it globally, you have to upload it to an Amazon cloud environment and have a virtual system, your virtual machine, using software that's not local. We've not really gotten a project that large yet to do that. We've been breaking it up into pieces.
I see. So maybe there's one way like the academic community could get involved is sort of like server systems. Like once you start scaling up, like would that be like having kind of easily accessible server systems where you can share data and publish them online even for people to analyze themselves?
Exactly. And that's really gaining steam a lot more is doing that. So
Cool. Can you comment on any sort of progress that's been made in that direction?
I cannot. We haven't really addressed that. We haven't aggressively pursued that yet.
Okay.
So, as we come across large data sets, then we may look at that.
Mhm.
I'm not trying to give you a runaround answer on that.
Yeah.
We've just not had a project that really required that yet. We recently came across one that we thought might have, but they didn't pan out, so that was okay. We didn't have to really pursue it. But you can always break it into pieces. I mean, keep it on local machines. Just makes it harder, especially when you're doing AI models. AI models don't like to use subset data. You have to have a training set, and those are usually large data repositories to train the model. So you can't do it in pieces.
Right. So like once you start getting like large volumes of sensor satellite data, then you employ AI techniques, then you need sort of centralized access to servers and different computing techniques.
Like the weather satellites are almost continuous. They're not continuous, but there's a lot of data that comes off of that. And there's a lot of hyperspectral data in orbit as well. I mean, that's where it's used heavily, is in orbit, looking down.
Okay. And maybe how does so you guys are part of the American Institute of Aeronautics and Astronautics. Has it been easy to interface with different technical committees within AIAA? What kind of sort of cross organization collaboration have you been able to?
Yes, that's a great question. We were always a bit nervous that we're still there's still stigma associated with UAP, but one of the other there have been, I believe, two other not technical committees, but IOCs that have invited us to join and be a part of. And this year we have two papers that we're presenting UAP specific that we're presenting at one of the conferences that they didn't blink when they saw UAP, which indicates it's becoming more mainstream, right? If you don't, I mean, it gets peer reviewed. Don't get me wrong; these papers do get peer reviewed, but it doesn't have that stigma of we just want to stay away from it. So we were a little surprised that it got. Usually we present to something called, that's around aviation because we're about aviation safety. But we submitted the papers to a space and technology forum and they accepted them. So it indicates that we've come a long way in terms of getting rid of the stigma.
Right. Yeah, actually, former NASA administrator Bill Nelson, just under the Biden administration a few months ago, he was on campus just yesterday, and he spent like a minute or two talking about UAP and these fighter pilot encounters, and yeah, that was kind of interesting, like kind of unprompted. So yeah, I think it's kind of becoming a more ubiquitous topic and less stigmatized, and people are talking about it more openly.
Yes. Yes. So we watch our reputation very well. We don't go down any holes. We'll entertain things, but only to a point. We want to stick to the science. And again, RGB, red, green, or blue. That's all we're doing. We're agnostic when it comes to what the cause is.
Any kind of final questions?
You're free to reach out to me anytime. You can share my email if anyone wants to questions or anything like that. Be happy to follow up with anyone.
Awesome. And do you have any like kind of closing sort of kind of calls to action or just sort of pep talks to give the academic community about UAP research and your organization? Like,
again, the mantra is to seek the truth of what's out there. So just keeping, I mean, just measuring the temperature of the environment is important to destigmatize it. So I don't know how many people are in the community that you're in, how they feel about the UAP, but it's changing and it's gaining credence just by these congressional committees. So that makes it a little easier. So I'm just it's your career, so I really don't have a lot of advice on that. But just as an open-minded, critically thinking person, just realize that whatever these are, they're real. I don't know what they are. We don't know what they are, but they are real. So if there's any kind of ideas or technology ideas, anything like that, we're open to that. It's no longer a question of there's things in the sky. They're there. We just don't know why or what.
Yeah, well, yeah.
They are a safety hazard. So that's why we're really addressing it, at least at the AIAA, is about the safety considerations. I mean, there have been some pretty aggressive moves by some of these objects to aircraft, according to certain pilots, right under the wings, right? And that's a safety issue.
Yeah, and actually that kind of segues. So we're going to have Sean Prochnicki come speak in 2 weeks. So like this talk has been about the hardware side, detection, radar systems, and a lot of these kind of pilot encounters and event reporting.
Yes.
That's maybe like harder to analyze with an array of radar data, but you get some more kind of juicy stories about how these things are interfacing with civilian and military airliners. And there's going to be a lot of discussion on that sense. How do you, like, the human side, like pilot side, and so we're going to have another talk in a couple weeks about that with AIAA. And thanks so much for sharing what your group is up to. I think it's like really important to destigmatize this topic and get the information out there so that a broader community of people can work on this stuff. And it's really great work that you guys are doing. And
well, again, thank you for inviting us. It was a pleasure being here. And again, feel free to reach out with any questions. We're here to be very open and transparent. Thanks again.
all right. Thank you, Rex. Cool. So I'll stick around for a minute or two, but yeah, I guess meeting adjourned.
Okay. Thanks again.